Good morning, friends. This is my second lecture on the same topic, that is the thermodynamics. And in this lecture, the in previous lecture, the last bit remains due to technical problem. Just we start from that point. That is the thermodynamic equilibrium. It is thermodynamic equilibrium. What is thermodynamic equilibrium? Now, see here, before going to start, just consider a cylinder. Just consider a cylinder filled with certain amount of gas. Cylinder filled with certain amount of gas. This gas is filled here. This gas is filled. And it is fitted with a wetless rigid movable piston. It is fitted with wetless rigid movable piston like this. It is fitted with wetless rigid movable piston, isn't it? Like this piston is placed, isn't it? Now, as gas is filled in the cylinder, in the sense it is a one system, and that gas has some state functions, like it has some specific pressure value, it has some specific temperature value, and also it has definite or fixed volume is there. So that's why it is the pressure, that is the, suppose gas has pressure P1, volume V1, and temperature suppose T1, isn't it? So these are the state functions of that gas which is filled in the cylinder. Now, as long as these state functions, these state functions have fixed value, isn't it? As long as these state functions have fixed value, then what happens? The piston also remains at fixed position. Piston also remains at the fixed position. Means movement of piston is not there. Observe. Means piston does not move either in upward direction or downward direction. Why? Because state functions have fixed value. State functions have fixed value. So due to the fixed value of the state functions like pressure, volume, and temperature, piston does not move in either upward or downward. Means it remains at fixed position. Such state of system we call as that system is under thermodynamic equilibrium. That system is under thermodynamic equilibrium. Means we say that the system is said to be under thermodynamic equilibrium if the state functions, do not vary with time. If state functions do not vary with time, then we say that system is under thermodynamic equilibrium. Now suppose by means of some reason, if suppose we increase the pressure over the system, means if I put some weight, here weight, isn't it, over the piston. If we put the weight over the piston, then what happens? Piston automatically, that piston goes downward. It compresses the gas, and due to which compression, the pressure and volume values changes. During that course, when pressure and volume going to be changes slowly, during that course, from initial to final, isn't it? Means piston pushes the piston in downward direction, that gas compress the gas, and after some time it remains steady or stable. Where it attains new equilibrium state. And at this condition, the gas has pressure suppose P2, volume V2, and suppose temperature is the same T1. Now in this case, state function in final state are the P2, V2, and T1, which are different from the initial state. But during that course of transformation of system from the initial state to final state, midway or mid path between transformation from initial to final state, the system is under non-equilibrium condition. What is non-equilibrium condition? So initial state, equilibrium state. Final state, equilibrium conditions. But during the transformation, system is under non-equilibrium state. Why? Because pressure and volume and other parameters slowly changes. And when it becomes again fixed, then system attains new equilibrium state. If you continue further in a third state, again there is a non-equilibrium state. When system state functions remains constant, position of piston remains fixed, and system attains third equilibrium state, and so on, isn't it? So thermodynamic equilibrium is nothing but system is said to be under thermodynamic equilibrium if the state functions do not vary with time. do not vary with time is called as a thermodynamic equilibrium. Okay. Now the next point that is very important, that is the types of process. Types of process. Now process means what? Yes, process means transition from one equilibrium state to another equilibrium state. That is transition from one equilibrium to another equilibrium state. This transition is nothing but it is called as a process. Process. So process is simply defined as a transition of system from one equilibrium state to another equilibrium state. That is path is called as nothing but process one. Isn't it? Now system can be transferred from one state to another state. From one state to another state, that system can be transferred by means of various methods or by means of various ways. So what are the ways by means of which one can carry out the changes in system from initial to final? So depending upon that, processes are classified into 4 classes. And these are the types of process. So first one we are going to study, that is the isothermal process. Now if you consider isothermal process, so name itself indicates iso in the sense constant. And again thermal in the sense temperature. Means the isothermal process is the process which is carried out. Yes, which is carried out at constant temperature. Yes, the process which is conducted or carried out at constant temperature is called as an isothermal process, isn't it? From initial to final, during that course, temperature must be kept constant. And during the conversion of system from one equilibrium state to another equilibrium state, if the temperature remains constant, in the sense there must be exchange of heat between system and surrounding. Because until and unless there is an exchange, temperature does not remain constant. जोपर्यंत त्याच्यामध्ये एक्सचेंज होणार नाही तोपर्यंत टेम्परेचर कॉन्स्टंट राहणार नाही. नाउ सी हाउ इट कॅन बी एक्सप्लेन्ड. Consider a system, isn't it, in which suppose a chemical reaction is carried out. Suppose A plus B, suppose it gives C plus D, isn't it? Simply chemical reaction is carried out in a system, isn't it? And suppose we want to bring this change, transition, this process is isothermal, means temperature is constant. Now as temperature is constant, in the sense within that system's temperature must be constant during the transition from one state to other state. But suppose if this reaction is exothermic, becomes exothermic in nature. So as reaction is exothermic, then what happens? During the course of that reaction, heat energy must be released. Heat energy must be lost. And as heat energy must be lost, it remains within that system. So automatically temperature of system increases. Which does not remain constant. And reversely, if you consider endothermic, suppose endothermic reaction is there, then during the endothermic reaction, heat energy must be required. And if heat energy required, in the sense molecules, that is the reactant molecules, they use itself, means their internal energy is utilized to bring about the reaction. That's why temperature decreases. One. So due to this, the wall, if the wall is not thermally insulated, then what happens? Yes, the wall is not thermally insulated, then what happens? If exothermic, then it gives the excess heat to the surrounding and keeps the temperature constant of system. And if it needs the heat, then it withdraws the heat from the surrounding again to keep the constant temperature. That's why there must be exchange of heat between system and surrounding in case of isothermal process. There must be exchange of heat between system and surrounding. If there is no exchange of heat between system and surrounding, then yes, it becomes adiabatic process. It becomes adiabatic process. Just we see after sometimes adiabatic process. And in isothermal process, as temperature is constant, so internal energy also constant. Internal energy also constant. As temperature is constant, internal energy is constant. So temperature constant in the sense initial temperature suppose T1 is suppose 25 degrees Celsius, and if remains it transferred to final temperature or final state, initial state of system where temperature is T1, and suppose if system is transferred to final state where temperature is T2 and again it is constant 25 degrees Celsius. So change in temperature, yes, change in temperature delta T is equal to T2 minus T1, it becomes 0. It becomes 0. So change in temperature delta T is 0 for isothermal process. Okay. So this is overall about isothermal process. Then next, it is the isobaric process. Then next, that is the isobaric process. Second. Isobaric process. Now isobaric process in the sense, again, iso in the sense constant. Iso in the sense constant, and bar, it is the one of the units to measure the pressure. So bar in the sense pressure means the process which is carried out or conducted at constant pressure throughout the transformation is called as an isobaric process. Then pressure must be remains constant. Pressure must be remains constant throughout the transformation. So P is constant. So as P is constant, therefore delta P is equal to 0. Delta P is equal to 0 means example, that is the all chemical reactions which are taking place in open container. ओपन कंटेनरमध्ये जेवढे केमिकल रिॲक्शन्स आपण कन्सिडर करणार ते सगळे कशामध्ये येणार, दॅट इज द आयसोबारिक प्रोसेसमध्ये. कारण ओपन कंडिशन जर कन्सिडर केला बेकर किंवा हे, तर ओपन कंडिशनमध्ये एखादी केमिकल रिॲक्शन स्टडी करणार असाल तर त्यावेळेला ओपन कंडिशनमध्ये असताना ओपन कंडिशन ॲटमॉस्फिअर प्रेशर ह्या कोणीकल फास्टमध्ये एखादी रिॲक्शन होत असेल तर ॲटमॉस्फिअर प्रेशर काय आहे, कॉन्स्टंट. Atmosphere pressure constant. So similarly, all chemical reactions taking place in open vessel or container comes under isobaric process. Okay. Then next, third one, that is the isochoric process. Isochoric process. Now isochoric process again same. Iso in the sense constant. Chor in the sense it is volume. It is volume. So which is process which is carried out at constant volume. At constant volume. At constant volume. The process which is carried out or conducted at constant volume is called as an isochoric process. And that is the all chemical reactions which are carried out in closed container. In closed container. जेवढे closed container मध्ये जेवढे reactions आपण carry करणार, conduct करणार, they all comes under isochoric process, isn't it? Isochoric process. And last one remains, that is the adiabatic process. Adiabatic process, fourth one. Now as far as adiabatic process is concerned, adiabatic process in the sense you have to first imagine adiabatic process in the sense thermos flask in front of you. Imagine. So if you consider a thermos flask type structure, means where the walls are insulated, where the walls are thermally insulated, and as walls are thermally insulated, in the sense suppose if chemical reaction is carried out, A plus B gives C plus D, A plus B gives C plus D, then what happens? As thermally walls are insulated, that's why in adiabatic process which is carried out in insulated container where walls are thermally insulated, and if the reaction is exothermic, then heat energy is given out. Yes, in exothermic reaction heat energy is given out, and as heat energy is given out, in the sense if this reaction is exothermic, then during the conversion of AB into CD, some heat is released, and released amount of heat remains within the system. It does not pass to the surrounding. Why? Because walls are thermally insulated. And that's why temperature of the system increases. And if suppose vice versa, if reaction is endothermic, then temperature of system decreases. So it is the adiabatic process where Q remains 0. Means there is no exchange of heat between system and surrounding. So major difference between isothermal and adiabatic, in isothermal there is an exchange, that's why temperature constant. But in adiabatic there is no exchange of heat, that's why temperature increases or decreases depending upon the what type of reactions is going on in that thermally insulated container. Okay. Now these processes, that is the isothermal process, adiabatic process, isochoric process and isobaric process, they are carried out by means of two ways, that is reversible and irreversible. So first we are going to study reversible process. Reversible process. Now what is meant by reversible process? Now see here, reversible process. So you know that the reversible symbol, you familiar with this reversible symbol, that is a double-headed arrow. It is in forward as well as in backward. This is the reversible symbol. What it indicates? It indicates that the reaction is possible in forward as well as in backward direction. So if I write here A plus B gives C plus D, the meaning of this is the A and B reacts with each other to give C and D, and after some time CD combines to form AB. Again after some time there is an equilibrium established between the whole reaction. That is forward and backward reactions are equilibrium. So this is the reversible symbol in chemical reactions. This is called reversible chemical reaction. But we are going to study reversible process, which is totally different from the reversible chemical reactions. So one of the most important point, remember that this reversible symbol and reversible process, they are different. They are different. This is the in thermodynamic concept, a reversible process. Now reversible process means what? See, just we want to define. Reversible process is the process in which the driving force is infinitesimally greater than opposing force. Driving force infinitesimally greater than opposing force, and whole process can be reversed at any stage by slight increase in opposing force. This is called as a correct definition of reversible process. That is the process in which driving force and opposing force are infinitesimally differs from each other, where driving force is greater than opposing force, and the whole process can be reversed at any stage, very important, at any stage by slight increase in opposing force. Just we explain this reversible process by means of some one concept here. Now suppose here marker is there and thread is there. We tie the marker with thread, isn't it? Now here first explain irreversible process. Now suppose here I held the one terminal of the thread in my right hand and here marker is on my left hand, isn't it? Now if I leave the marker as it is, then it stops at the last position, end of that board, isn't it? At the end of the board, isn't it? It does not stop at the middle part or middle position of the board, isn't it? So just if I leave the marker, it stops at the end, isn't it? At the end. So this is one case. Suppose another method, just if I leave the marker slowly, isn't it? And if I want to revert that marker to the original position, then just I increase the opposing force like this, it comes again back. If suppose I leave again and suppose I want to revert it from that position, again revert it, isn't it? So that is the driving force and opposing force greater by differs by infinitesimally small amount, and whole process can be reversed at any stage. In this case you cannot revert, just as you leave it, you cannot revert the marker from the middle position. When it leave that marker, it ends at the last moment, isn't it? But in this case, if I want to revert from the any position, just I want to revert from here position, I will pull the thread. Just if I want to revert from this position, I pull the thread. So during that course, it can be reverted at any position. So it is reversible process. It is a reversible process. Okay? Then some features are there reversible process. One feature, that is the driving force and opposing force differs by infinitesimally very small amount. Infinitesimally small amount मध्ये differs असतात. Then process carried out, reversible process can be carried out in infinite number of steps. Infinite number of steps, isn't it? And the maximum work is obtained from reversible process. Now it is maximum work is obtained from reversible process. It is the next point in the topic, isn't it? So these are some characteristic features of reversible process. One more point, that is a system is always in thermal mechanical equilibrium at the end of the process. Okay. Do you understand? I hope you understand the reversible process. Then next, this is the nature of heat and work. Nature of heat and work. Now, what is the nature? Why we have to study nature of heat and work? Now see, already I told you that in the introduction, every body has some sort of energy. And energy of body, that is, we can define, that is the capacity of body to do work. It is the energy. Energy is nothing but capacity of body to do work. So every body means, that is the energy of body or system. Suppose here system. Okay, energy of system exchanges with surrounding. Suppose it is surrounding. Okay, energy of system exchange with surrounding. Exchange in the sense it is in both direction, from here also and here also, isn't it? Energy of system exchanges with surrounding by means of two ways, either in the form of heat or in the form of work. Means we can say that work and heat are the two agents. By means of which system exchanges energy with surrounding, isn't it? Work and heat are the two agents by means of which system exchanges its energy with surrounding, either in the form of Q or in the form of work. So first, that's why we have to study the heat and work. Study is important in thermodynamics. So first, we are going to study what is the work. Isn't it? Work. Now in the chemical thermodynamics, the work is nothing but we have to study the pressure volume type of work. But before that, in physics, you know that work is nothing but force into displacement, isn't it? Force into displacement is called as an work. But here we have to study the pressure volume type of work. Pressure volume type of work in the sense, that is the, again, same diagram. Consider container which is filled with certain amount of gas, fitted with frictionless rigid piston. Means moment of piston, due to moment of piston, the gas compress, its pressure may increases, decreases, gas expansion occurs. In the sense, there is a change in pressure and volume, and due to that change in pressure and volume, the piston, it is either moves in upward direction or it comes downward direction. Through a specific distance d. Through a specific or some amount of distance is there, moment occurs of that piston due to change in the pressure and volume of that gas. So due to that one, we call as a pressure volume type of work. We call as a work done in chemical thermodynamics as a pressure volume type of work. Now that for that purpose, if we consider pressure volume type of work PV, then we know that P is nothing but force per unit area. And volume is V. Suppose if during the change in pressure and volume inside the cylinder, if the piston moves, suppose through a distance d, moment occurs, yes, then F divided by area is nothing but, it is d square, and volume is nothing but dq. So d square cancels with dq, it becomes F into d. That is the pressure volume type of work is nothing but FD. That is the FD work, isn't it? Now here the work are of two types. Two types of works are performed, isn't it? Means piston when moves in upward direction, it is one kind of work performed by system, and when piston moves in downward direction, another kind of work is performed by that system, isn't it? So here just I explain that by taking an example. Suppose the piston, here piston, isn't it? It is filled with, suppose, hydrogen peroxide. It is filled with hydrogen peroxide, H2O2, liquid state, H2O2, liquid state, hydrogen peroxide filled केलं, and again it is fitted with weightless, frictionless, rigid, movable piston. Okay, it is fitted like this. Okay, and here we put some small weights over the piston. We put small weights, isn't it? Now what happens here? See, hydrogen peroxide. Here piston, position of piston is fixed. Position of piston is fixed, isn't it? Initial state. Now what happens here? If we write the reaction, it is hydrogen peroxide, H2O2 liquid twice. If it decomposes, it gives twice H2O liquid plus, yes, O2 gas. Plus O2 gas in upward direction. Isn't it? O2 gas. Means after some time there is a decomposition of hydrogen peroxide occurs. And due to decomposition, one of the product formed is in the gaseous state. It is in gaseous state. So as gas oxygen is produced inside the cylinder, then what happens? It pushes the piston in upward direction. Due to which piston moves in upward direction, and I can show here in the another diagram. That is, the piston moves in upward direction. Like this. Here oxygen gas is formed and water. Okay. Suppose it moves through a distance, suppose D. It moves through a distance D in the final state. So during the motion of piston in upward direction, here the energy of that system exchanges with surrounding in the form of two ways. It is the heat and Q. Work and heat. But here suppose no heat transfer occurs. If you assume there is no heat transfer occurs, then the energy of system that is utilized in pushing the piston in upward direction is nothing but it is completely converts into work. Means we say that is the here energy lost by system is exactly equal to work done on surrounding, isn't it? Energy lost by the system is exactly equal to work done by the system if this condition is very important. If no heat transfer occurs. म्हणजे ह्या पिस्टनला इथून वरती पुश करण्यासाठी आतमधल्या गॅसला जी एनर्जी लावावी लागणार आहे ती एनर्जी कशामध्ये कन्वर्ट झाली? दॅट इज इट कन्वर्ट्स इनटू वर्क डन by the system on the surrounding. If no heat transfer occurs. Remember well. If no heat transfer occurs, isn't it? This is the one way where piston moves in upward direction, isn't it? You call as a work of expansion also. Now suppose here one more example. Suppose cylinder, and then cylinder, if we place the ammonia gas and hydrochloric gas, this ammonia gas plus HCl gas are filled, and it is fitted with weightless, rigid, movable piston with some weight over the piston. So these are the gases, ammonia gas and HCl gas is there. It is initial state. After some time the reaction occurs within that system is ammonia gas plus HCl gas. Yes, simply adds to form NH4Cl solid, and solid in the sense in downward direction. So here what happens? Yes, initially they are in gaseous state, ammonia and HCl. So as they are gaseous state, yes, the gases has some pressure, and due to that pressure the piston here stops, or position of piston is constant here. But when ammonia and HCl reacts with each other to form ammonium chloride, NH4Cl, it is in solid state. It settles at the bottom. That is NH4Cl. NH4Cl settles at the bottom in solid state. as it settles at the bottom, there is a vacuum is created within that cylinder, and as vacuum is created, therefore piston moves suddenly in downward direction. It moves in downward direction. In the sense, the movement of piston is from in downward direction, isn't it? So here, if suppose here the work is done by the surrounding, because due to energy, means gases are consumed to form NH4Cl, so piston moves in downward direction within that system. Therefore work is done by the surrounding. So work done by surrounding is exactly equal to energy gained by system. Due to that downward movement of piston, energy is gained by the system. Okay, so there are two cases where the piston moves in upward and downward, isn't it? Then it is not most important point is the sign conventions. The sign conventions are here. Sign conventions. Sign conventions is very important. Sign conventions. Now, if you consider a system, this is a system. If you consider system, isn't it? Okay. Now, remember well, I told already that the energy of system exchange with surrounding in the form of two ways. One is the heat and one is the work. So, system either gives energy to the surrounding either in the form of work or in the form of heat, or it may acquires the energy from the surrounding either in the form of work or in the form of heat, isn't it? So remember well, if here suppose work done on the system, suppose work done by the system. Okay, so as work is done on the system means system वरती work झालेला आहे, isn't it? So it is energy is given to the system. In the sense it is positive W plus W. Work done by the system कडून work झालेला आहे, isn't it? It is minus W. Now here similarly, if heat given to system, so as heat is given to the system, it increases the energy of system, isn't it? It is plus Q. And heat lost by the system, in the sense it is given from the system, that's why it is minus Q, isn't it? So